Stoves. Biomass cookstoves have been in use for cooking needs since prehistoric times. Even today, the majority of the rural population is partially or completely dependent on biomass cookstoves. Worldwide, more than 2 billion people today cook on traditional stoves and open fire using fuel wood, crop residues, animal dung cakes, and other biomass as fuel. For me personally, cook stoves are very important because I started in parallel along with Biochar my research on biomass cook stoves and have facilitated efficient low cost stoves extensively. Even my understanding about Biochar is so much because of my involvement in designing cook stoves, where I could completely understand the process of combustion of any biomass. And those fundamentals are very much important in my life even now as a professional helping many people in the area of biochar, right from pyrolysis to application process. Here the involvement with community and the discussions that happened with them in the context of cook stoves as well as and the byproduct biochar from the cook stoves was also an important aspect that I taught people that they could add on to their soils or otherwise they had been doing traditionally. So here in this picture that one could clearly see that along with the cow dung, the charcoal and ash from their cook stove ended up in the farmyard manure pit. This goes directly to the field as manure. So traditionally the people had been doing this. Worldwide, more than 2 billion people today cook on traditional stoves and open fire using fuel wood, crop residues, animal dung cakes, and other biomass as fuel. Charcoal from stoves is one of the sources of biochar. Otherwise, the temperature at which this charcoal is produced has the qualities of biochar. I have tested some hundreds of cook stoves as part of my research on efficiency of stoves. There I used to measure the temperature in the fire where biomass is being burnt. On an average, it ranged to up to around 700-750 degrees on the higher level, and on the lower level, it was like around 400-450 and above. So, if we take the average in between, say around between 560-600 degrees centigrade, that is very optimum. And even if you see the research studies, biochar produced say around 500-550 degrees centigrade had the best quality for amendment to soils as biochar. Stoves that can use crop residues as a fuel source can also address the problem of sustainable disposable and use of biomass. Here, for me, another fundamental challenge was when I started facilitating cook stoves and people had been asking from where they will get the biomass and it should be renewable. So again I started thinking how the biochar from the very cook stoves could also add on to improving the fertility of the soils along with other amendments and increase the availability of total biomass apart from other benefits like yield, production, growth. So this way it was a solution for me. The efficient cook stoves and the source of biochar extracted. Intentionally one has to extract here. And my cook stoves yielded high quantity of biochar because I had the gas-fire stoves also, that is forced air or natural draft and top lit updraft cook stoves, and including the efficient cook stoves. And I have designed around 25 top lit updraft or gas fire stoves, including natural draft and forced draft stoves. On an average, these stoves yield 14% biochar of the total quantity of wood used, that is the minimum. Cooks should recover the biochar left after cooking by removing charcoal from the stove and quench it with water. The actual recovery of biochar in a cook stove depends on the practice adopted. That is, we have to teach communities to extract the embers, quench it with water. Otherwise, if they leave in the stove itself, it is going to get converted into ash. Again, the stove design is also an important aspect. Do you facilitate a process where they can conveniently extract this charcoal and quench it? In my make series designs, I have given that facility at the bottom so that the people could easily extract and then quench. And here again, I have worked with the communities, teaching them the importance of this biochar for the soil. So here added the willingness of the people who are cooking. Here are my stoves which had been tested for the amount of biochar that they yielded. Make 3G stove 14%, Make 3G stove steel version about 19%, My Home stove 16%, Make CM stove. This CM stove has 2-3 versions with forced air or natural draft air and up to 19%. The range of biochar yield is from 14% to 19% in the above gas-fire stoves. In comparison, the typical total yield of around 6% to 8% from 3-stone stoves invariably is too low to be considered as a source for biochar. Therefore, traditional cook stoves, especially the less efficient cook stoves the communities are using, here it is very difficult to train them on extracting this biochar.